So, your data is only as good as you can present it to other people, really. So let's talk about plotting and graphing your data and how to present that to others and make your graphs look pretty. We're going to introduce Matplotlib, which is a library you can use in Python to make pretty graphs. And I'll show you a few tricks on how to make them as pretty as you can. Let's go there. Let's have some fun with graphs. It's always good to make pretty pictures out of your work, and this will give you some more tools in your tool chest for visualizing different types of data, using different types of graphs, and making them look pretty. Use different colors, different line styles, different axes, things like that. So, it's not only important to use graphs and data visualization to try to find interesting patterns in your data, but it's also interesting to present your findings well to a non-technical audience. So let's dive into Matplotlib. Go ahead and open up the Matplotlib IPython notebook and you can play around with this stuff with me. We'll start by just drawing a simple line graph. So in this example, I'm going to import matplotlib.pyplot as plot. And we'll just refer to it as PLT from now on in this notebook. And what I'm going to do is use numpy.arange to create an x-axis filled with values between -3 and 3 at increments of 0.001. And I'm going to use pyplot's plot function to plot x, and the y function will be norm.pdf of x. So I'm going to create a probability density function with a normal distribution based on the x values. And I'm using the SciPy stats norm package to do that. So tying it back into our earlier lecture about probability density functions, here we are plotting a normal probability density function using Matplotlib. So we just call the pyplot plot method to set up our plot, and then we display it using plot.show. And when we run that, that's what we get. A pretty little graph with all the default formatting. Let's say I want to plot more than one thing at a time. So you can actually call plot multiple times before calling show to actually add more than one function to your graph. So in this example, I'm calling my original function of just a normal distribution. But I'm gonna render another normal distribution here as well, with a mean around 1.0 and a standard deviation of 0.5. And I'm going to show those together so you can see how they compare to each other. And you can see by default, Matplotlib chooses different colors for each graph automatically for you, which is very nice and handy of it. There you have it. If I want to save this to a file, maybe I want to include it in a document or something, I can do something like this. Instead of just calling plot.show, I can call plot.savefig with a path to where I want to save this file and what format I want it in. So in this example, I have the same plot set up, but instead of show, I'm calling savefig to this path, and you'll want to change that to an actual path that exists on your machine if you're following along. You probably don't have a users frank folder on your system. And remember too, if you're on Linux or Mac OS, instead of a backslash, you're going to use forward slashes, and you're not going to have a drive letter. So with all of these Python notebooks, whenever you see a path like this, make sure that you change it to an actual path that works on your system, okay? But I am on Windows here, and I do have a users frank folder, so I can go ahead and run that. And if I check my file system under users frank, sure enough, I have a myplot.png file I can open up and look at, and I can use that in whatever document I want. So pretty cool. All right, let's move on. Let's say I don't like the default choices of the axes of this value. Like it's automatically fitting it to the tightest set of axis values that it can find, which is usually a good thing to do, but sometimes you want things on an absolute scale, right? So in this example, I'm setting the x limit using, first I get the axes using plot.axes, and once I have these axes objects, I can adjust them. So by calling setXlim, I can set the x range from -5 to 5, and set ylim, I set the y range from 0 to 1. And you can see that down here, my x values are ranging from -5 to 5, and y goes from 0 to 1. And I can also have explicit control over where these tick marks are. So I'm saying I want the x ticks to be at -5, -4, -3, etc., and y ticks from 0 to 1 at 0.1 increments. Now I could use the arange function to do that more compactly, but the point is you have explicit control over where exactly those tick marks happen. And you can skip some. You can have them at whatever increments you want or whatever distribution you want. Beyond that, it's the same thing. Once I've adjusted my axes, I just call plot with the functions that I want to plot and call show to display it. And sure enough, there you have the result. What if I want grid lines? Well, same idea. All I do is call .grid on the axes that I get back from pyplot.axes. And by doing that, I get these nice little grid lines. And that makes it a little bit easier to see where a specific point is, although it clutters things up a little bit. So a little bit of a stylistic choice there. What if I want to play games with the line types and colors? You can do that too. So you see here there's actually an extra parameter on the plot function where I can pass a little string that describes the style of the line. And in this first example, what this indicates is I want a blue line with a solid line. That's what the B stands for blue, and the dash means a solid line. And for my second function, I'm going to plot it in red. That's what the R means. And the colon means I'm going to plot it with little vertical hashes all the way up. If I run that, you can see that's what it does. And you can change different types of line styles there. In addition, you can do a double slash, or a double dash rather. And that gives you this dashed line as a line style. I can do a dash dot, and you can get something that looks like that. So those are the different choices there. I could make it green with vertical slashes. And there you go. So have some fun with that if you want. Experiment with different values, and you can get different line styles. Something you'll do more often is labeling your axes. You know, you never want to present data in a vacuum. You definitely want to tell people what it represents. And to do that, you can use the X label and Y label functions on PyPlot to actually put labels on your axes. So I'm going to label the X axis greebles and the Y label probability. And you can also add a legend inset here. Normally this would be the same thing, but just to show that it's set independently, I'm setting up here a legend, and you pass in basically a list of what you want to name each graph. So my first graph is going to be called Sneeches, and my second graph is going to be called Gax. And the loc parameter here indicates what location you want it at, where 4 represents the lower right-hand corner. So let's go ahead and run that. And you can see that I'm plotting greebles versus probability for both Sneeches and Gax. Little Dr. Seuss reference for you there. So that's how you set axes labels and legends. Little fun example here, if you're familiar with the webcomic XKCD, there's a little bit of an Easter egg in Matplotlib where you can actually plot things in XKCD style. And you can do that by calling plot.xkcd, which kind of puts Matplotlib in XKCD mode. And after you do that, things will just start to look with, like this style with kind of a comic book font and squiggly lines automatically. And this little simple example shows a funny little graph here where we're plotting your health versus time, where your health takes a steep decline once you realize you can cook bacon whenever you want to. And all we're doing there is using this XKCD method to go into that mode. A little bit of interesting Python here and actually how we're actually putting this graph together. So we're starting off by making a data line that is nothing but the value 1 across 100 data points. And then we use the old Python list slicing operator to take everything after the value of 70, and we subtract off from that sublist of 30 items the range of 0 through 30. So that has the effect of subtracting off a larger value linearly as you get past 70, which results in that line heading downward down to 0 beyond the point 70. So a little example there, some Python list slicing in action there, and a little creative use of the arange function to modify your data. Now going back to the real world, we can remove XKCD mode by saying RC defaults on Matplotlib, and we can get back to normal mode here. If you want a pie chart, all you have to do is call plot.py and give it an array of your values, colors, labels, and whether or not you want items exploded, and if so, by how much. So you can see here I'm creating a pie chart with these values, 12, 55, 4, 32, and 14. I'm going to assign explicit colors to each one of those values, explicit labels to each one of those values, and I'm going to explode out the Russian segment of the pie by 20%. And I'm going to give this plot a title called Student Locations and show it. And that's all there is to it. If I want to do a bar chart, also very simple. Kind of a similar idea to the pie chart. You give an array of values and an array of colors, and you just plot your data. So I'm telling it to plot from the range of 0 to 5 using these y values in this array and using this explicit list of colors. Go ahead and show that. And there you have your bar chart. And a scatter plot. This is something we'll see pretty often in this course. So say you have a couple of different attributes you want to plot for the same set of people or things. For example, Maybe we're plotting ages against income or something for each person, where each dot represents a person, and these axes represent different attributes of those people. The way you do that with a scatter plot is you call Matplotlib with scatter, using the two axes that you want to define, the two attributes that contain data that you want to plot against each other. So let's say I have a random distribution in X and Y, and I scatter those on a scatter plot, and I show it. This is what it looks like. Pretty cool. So you can see there's sort of a concentration in the center here because of the normal distribution that's being used in both axes, but since it is random, there's no real correlation between those two. Finally, we'll remind yourselves how a histogram works. We've already seen this plenty of times in the course, but if you just call, for example, a normal distribution centered on 27,000 with a standard deviation of 15,000 with 10,000 data points, I can just call Matplot's histogram hist function, and you specify the input data and the number of buckets that you want to group things into in your histogram, and just call show, and the rest is magic. Finally, box and whisker plots. So remember in the previous lecture when we talked about percentiles, I touched on this a little bit. Again, with a box and whisker plot, the box represents the two inner quartiles where 50% of your data resides, and conversely, another 25% resides on either side of that box. But these dotted line whiskers represent the range of the data except for outliers. So we define outliers in a box and whisker plot as anything beyond 1.5 times the interquartile range, or the size of this box. So we take the size of that box times 1.5, and up to that point, that's what we call these outer quartiles. But anything outside of that is considered an outlier, and that's what these lines represent here. That's where we are defining outliers based on our definition with the box and whisker plot. Now, just to give you an example here, we've created some fake data set where we have a uniform random distribution of data, and then we add in a few outliers on the high end and a few negative outliers as well, and then we concatenate those lists all together and create a single data set from these three different sets that we created using NumPy. We then take that combined data set of uniform data and a few outliers, and we plot it using plot.boxplot, and that's how you get a box and whisker plot. Call show to visualize it, and there you go. So you can see that it's showing that box that represents the inner 50% of all data, and then we have these outlier lines where you can see little crosses for each individual outlier that lies in that range. All right, that's Matplotlib, your crash course. Get your hands on it. Actually do some exercises here. So as your challenge, I want you to create a scatter plot that represents random data that you fabricate on age versus time spent watching TV. And if you can make that anything you want, really. If you have a different fictional data set in your head that you'd like to play with, have some fun with it. So create a scatter plot that plots two random sets of data against each other, and label your axes, make it look pretty, play around with it, have fun with it. Everything you need should be in this Python notebook that you need for reference and for examples, but if you have any trouble, feel free to post in the discussions for this lecture and we'll help you out. So keep that IPython notebook around with your tips and tricks for Matplotlib. It's kind of a cheat sheet, if you will, for different things you might need to do for generating different kinds of graphs and different styles of graphs, so I hope it proves useful.